do we know whether or not we can use the limit comparison test to determine the convergence of a series? Well, we have to meet 3 criteria. First, the series itself always has to be greater than or equal to 0. So for example, with this series, when we plug in n equals 1, 2, 3, 4, etc., every term has to be 0 or positive. We can't get any negative values. So this series would meet that first requirement. Second, the comparison series we pick always has to be positive. Let's say we pick this comparison series. We can see that we'll always get a positive value when we plug in n equals 1, 2, 3. So we meet that requirement as well. Finally, when we take the quotient of the original series divided by the comparison series, and then we take the limit of that quotient as n goes to infinity, we'll get some value that we call capital L. Now, if L is between 0 and infinity, meaning that it's both positive but also a finite number, not infinity, then we've met all 3 requirements and we can apply the limit comparison test, which tells us that our series diverges if the comparison series diverges, or that our series converges if the comparison series converges.